Hi everyone, welcome to Let's Code. In this video we are going to learn how to create our first supervised neural network model that will take an input of handwritten digits and tells us which digit it is. In this project we will be creating supervised learning model. First we will get an idea of what is supervised learning. In supervised learning we will give data to our model and label the correct output and train based on this data. Here we are using MNIST handwritten digit dataset, one of the most common dataset, which contains 60,000 images for training and 10,000 images for testing our model. What our model is supposed to do, it will go through multiple images of each of the digit and identify a pattern for each digit. Each digit have a label attached to it so that our model will learn about label based on the digit image. After training, when we test our model with test dataset, then it will be able to identify the digit in provided image. You can find this dataset in a lot of places like Kaggle, TensorFlow. We are going to use TensorFlow for our project. TensorFlow is a machine learning library developed by Google. It is used for research and production at Google. We are also going to use Keras to build and evaluate our model. We will have MNIST dataset available here. Here we see images of 28 by 28 pixel and also see labels associated with it. Let's create a Jupyter notebook inside a virtual environment. First we'll create a new virtual environment with commands python m venv. Then we will activate this virtual environment with source venv bin activate command. Then we will install Jupyter, TensorFlow, NumPy, Matplotlib. To install all the necessary dependencies for our project. Let's see the different steps to write our code. First we will load the dataset from TensorFlow. Then we will create the model. After creating the model, we will compile the model. Then we are ready to train our model. We will train our model with MNIST train data. At last we will evaluate our model. Let's open Jupyter Notebook with Jupyter Notebook command. Then go to new Python 3 and create a new notebook. Before loading the dataset, let's import all the required libraries. We will import TensorFlow. Then we will import layers and models from TensorFlow.keras. We will also import NumPy to deal with arrays. Other than NumPy, we are going to use Matplotlib for data visualization. We are going to create graphs to understand the data in a better way. Let's load our data from TensorFlow. tf.keras.datasets. It is having lot of datasets. We are using MNIST and then call load data function. If we hover over here, we can see what it is going to provide us. It is giving 60,000 28 by 28 pixel grayscale images of 10 digits along with 10,000 test images. Here we can see it is giving tuple of numpy arrays x train y train and x test y test. Here y train is label value. We have 60,000 label values. Let's load this in x train y train and x test y test variable. After loading the data, we will print x train variable. It's an array. Let's check the shape of it. It is 60,000 by 28 by 28. Similarly, y train shape has 60,000 values. These values are labels, integer from 1 to 9. Let's check shape of x test and y test. We will print first value from x train. Here we can see an array. Let's plot this using plt.imshow method. It looks like 5. We can also check this from y train. Here it is also 5. Now we have to build a neural network for our model. Before building a neural network, let's see what is a neural network. A neural network has input layers and output layers, and in between it has hidden layers. Now this looks like a complex diagram, but in our model we'll only have one hidden layer. Here in input layer, we are going to send input images of 28 by 28 pixel. We will flatten this 2D array into 1D array. It will become 784 neurons in input layer. Similarly, in output layer, we have 10 neurons possibility for each digit 0 to 9. So we'll have 10 neurons for each digit. Here every neuron is giving us the output, which is going to be probability of each digit, and the sum of total probability will be 1. Whichever digit will have most probability will be our answer. This model is working sequentially. Each layer after doing calculation give information to next layer. Let's write the code for creating our model. We will create sequential model from Keras. Here we have to mention the different layer. First layer will be input layer. We will flatten the input images. Our next layer will be hidden layer. We will have 128 neurons. We can have any other number of neurons like 100, 200, 256. Our accuracy of model will change based on number of neurons. We can tune this to achieve more accuracy. We will also give activation functions. Here we are using ReLU, which will identify hidden patterns in images. At last we have output layer. Here we will have 10 neurons, one for each digit. Here in activation function, we will be using softmax because we will have probability and total sum of probability is 1. Our activation function depends upon the problem we are going to solve, whether it is regression, classification. The more problem you will see, you will get to know which activation function to use. Let's run this. This will create our model. Now the model is created. Next we will compile our model with model.compile method. And we also have to give some configuration over here. We will give optimizer as ADAM and loss function as sparse categorical classification. It is used in multi-class classification, and our problem is similar to this. We are classifying our images to one of 10 classes. Now we will train our model with the help of model.fit function. Here we will pass xtrain, ytrain and epoch equal to 5. Epoch is the number of times we are passing our data to train the model. The bigger the number will be, the more accurate our model will be. After a certain point, it won't much improve further. Let's run this, where we can see that for the first time it is giving our data to model. After training, it will give accuracy and the loss function. The more number of epoch will be done, the accuracy will improve and loss will decrease. Let's evaluate our model. For evaluating our model, we will write model.evaluate and pass xtest and ytest variable. This will return test loss and test accuracy. Here we are evaluating test dataset. We can see here test accuracy is 0.9407, which is nearby training accuracy. Now we'll predict our values with test dataset. We will store this in a variable prediction. Now we'll check the shape of predictions. It is 10,000 by 10. Let's print first element in prediction. Here it is giving probability of each digit for the first image. Let's print the maximum probability. We will also verify this with printing x test of 1 and y test of 1. Now we have created our neural network model. If you find this helpful, please share and subscribe to the channel for videos like this. We will meet in our next video.